Hello everyone, and welcome to our 11.1 lesson on circumference and arc length. So in yesterday's lesson we found arc measure. Today we're going to be using some of those measures to actually figure out what is the length of that arc. If we were to flatten it out and measure it, what would be the length of the arc? And so to get started, we're going to review what the circumference of a circle is. Remember that the circumference is the distance around the outside of a circle. So all the way around the outside, and that circumference formula that we're going to be working with is circumference equals 2 pi r. So a silly way to remember it, for some reason this works, twinkle, twinkle, little star, circumference equals 2 pi r. Another thing that you can use is that the circumference is equal to pi times the diameter. I'm mostly going to be working with 2 pi r simply because the area formula has a radius in it, and so I'm just used to working with the radius instead of the diameter. But you can use either. So if that is the full circumference, the distance all the way around a circle, how do I find the distance just for a piece of that arc? So a piece of that circumference, which is an arc. If I were to flatten out L and measure how long it was, how would you use this formula in order to find the length of the arc? What you're going to do is it's going to be the circumference. So you're just taking your circumference, which is 2 pi r, and you are working with a fraction of that circumference. So what fraction of that circumference are you working with? You are working with x out of 360 degrees, whatever that central angle is. It's going to be x degrees out of 360 times your circumference. So another way to write this is x out of 360 degrees, where x is the central angle. This length, L, is going to be equal to x out of 360 times 2 pi r. So you're just taking a fraction of your circumference every single time. So what pieces do you need? You need to know x, which is going to be that central angle. Let me do that in a different color. You need to know the central angle, which is x. And then you also need to know the radius. The radius is going to give me that size of the circle. Okay. So the first few questions say to solve just for the circumference, the overall circumference. Leave in terms of pi and also approximate to the nearest tenth. So we're going to be doing both answers, in terms of pi and approximated to the nearest tenth. So in this first circle, what is my radius? My radius is 16. So if I want to find my circumference, it's going to be 2 times pi times r. My radius is 16. So what I'm going to do is I'm going to do 2 times pi times 16. So when you leave it in terms of pi, that means you type in everything else into your calculator, but you leave it in terms of pi, meaning how many pi's do you have? So that's going to be 2 times 16, which is going to give me 32 pi's. That's going to be 32 pi inches. That's my exact circumference. That's not rounded at all. What we're going to do for the second part of the directions is it says approximate that to the nearest tenth. So now we're actually going to type in the pi symbol, 32. We're actually going to use the pi symbol and not the, I do not want you using the 3.14. We want to use the pi symbol since we have that on our calculators. 32 times pi is going to give me about 100.5. It's about 100.5 inches, which makes sense because about triple 32 is about 100. So 100.5 inches is my rounded answer. You can see that this is approximated, whereas this one is exact. On a standardized test, they might leave it in terms of pi, or they might have you round it. So we're gonna get familiar with both and comfortable with both answers. Okay. So my circumference here was exactly 32 pi, which is about 100.5 inches. All right. This next problem is a little bit harder because we don't have a radius, we have the full diameter. So it is pretty easy, y'all are really good at this, it is pretty easy to find the radius from the diameter. What I'm going to do is I'm going to acknowledge that that whole thing is 22, so my radius is 11. And what I like to do is I like to go ahead and mark out the 22 so I don't accidentally use it. So you could have worked with pi d, but I'm going to work with 2 pi r every time just because I'm a creature of habit. So 2 pi r, circumference is going to be equal to 2 times pi times 11. So what is, whenever I type in everything except for the pi symbol, what is 2 times 11? That is going to give me 22 pi exactly. So my exact circumference is 22 pi, and then I am in meters. So what is that rounded 22 times pi? That is going to be 69.1 meters. If I were to roll out the circumference, if I were to take this circle and I were to flatten that out and roll it out, it would be 22 pi exactly, which is about 69.1 meters long. All right, again, I have another diameter on this problem, so we need to find our radius. So what is our radius going to be? That's going to be 35 divided by 2. It does give me a decimal, but it is okay to have a radius that is a decimal. If you measured a piece of your hair right now, it is more likely that that is going to be a decimal than a whole number. So it is okay to work with decimals. So circumference equals 2 pi r. So that is going to be circumference equals 2 times pi times 17.5. Again, you could have also done 35 times pi d, totally fine. And so that's going to give me 35 pi as an exact answer. If I wanted to know, well, what is that rounded, you would just type it into your calculator. 35 times pi is going to give me 109 point, oh, this rounds up, 0.95. So that's going to actually round up to 110.0. It's about 110.0. So I'm putting both my actual answer and my rounded answer. Let's keep going. I'm going to have y'all do some of these in class, so I would pause it if I were you. So 58 divided by 2. We're going to be working with our area soon where you have to have the radius. So that's the entire diameter. So that is going to make this 29 yards. If my diameter is 58, my radius is 29. I like to cross out the diameter after I'm done with it to know I'm only working with my radius. Circumference equals 2 times pi times 29, which of course is going to give me 58 pi yards exactly. What is 58 times pi? Whenever you do 58 times pi, you're going to end up getting, let's see, 58, oh goodness, y'all, I cannot get this to work. There we go. 58 times pi is going to give me 182.2. So that rounds to about 182.2 yards. All right. Let's keep going. We've got a few more of these, finding the full circumference. We're getting used to this again because it's been since the first semester since we did this. So here is my radius. So circumference equals 2 times pi times r, which is 15.6. So I'm going to double 15.6. When I get 15.6 times 2, that is going to give me exactly 31.2 pi centimeters. What is that 31.2 times pi, the actual value rounded? The exact value is 31.2 pi. The rounded answer is going to be about 98.0 centimeters. So about 98 centimeters. All right, 7 millimeters is my radius. So circumference equals 2 times pi times r. That's going to give me 14 pi millimeters exactly. 14 times pi is going to give me about 43.98. So that's going to round to 44 millimeters. Okay, so we're putting, every single time we're putting our rounded answer and we're putting our our rounded answer is the second one. Our exact answers in terms of pi are going to be that first answer. So what it's equal to and then what it's rounded to. I want y'all to get used to knowing that how to do each one. That way, no matter what the directions ask for on a standardized test, you are used to both. All right, so now what we're going to do is we're going to solve for the indicated value. And so this says that the circumference of a circle, it says round to the nearest tenth if necessary. The circumference of a circle is equal to 36 pi inches squared. Well, what do I know that circumference is equal to? What can I fill in for my formula? I can fill in 2 pi r. I know that circumference equals 2 pi r, so I can set that equal to 36 pi. And we want to solve for our radius. So what I can do is I can divide both sides by 2 pi. And when I do that, the pi's cancel out. 36 divided by 2 gives me a radius of 18. So I'd have a radius of 18 inches. My original radius must have been 18 if my circumference is 36 pi. Okay, I can do that again. Circumference equals 28 pi, so I'm going to plug in 2 pi r is my formula for circumference. That is equal to 28 pi. We want to find what our radius is, so I'm going to divide by 2 pi on both sides. The 2 pi's cancel out, and then the pi cancels out. What is 28 divided by 2? That gives me a radius of 14. Now pause here. If the radius is 14, this asks for the diameter. So if I want to find my diameter, I'm going to multiply. Diameter is going to be equal to 14 times 2. Double it. That gives you 28. Let me make sure I did that right. 49 pi. Yes, okay. So that is going to give me 28 centimeters. 28 centimeters. Okay. All right. And then now we have the circumference equals to 145 km. So let's plug in 2 pi r is my formula for circumference. That equals to 145. To get the radius by itself, I'm going to divide by 2 pi. This is where this is going to give me a decimal. And so I type in 145 divided by I'm going to make sure I put 2 pi in parentheses to show I'm dividing by 2 and pi, not just 2 and then multiplying by pi. So let my calculator know. You could also do 145 divided by 2, enter, and then divided by pi. This is going to give me about 23.1 for my radius. Now, it did not ask me for my diameter, so I'm going to leave that as the value for the radius. All right. So now we're working with finding arc length. So instead of finding the entire circumference, I'm just finding these blue amounts. So you can see that they're darkened. I'm going to darken them even a little bit more so you can see them. So all of these should be a value less than the total circumference because this is a fraction of the circumference. So it says solve for the arc length, leave as a fraction and in terms of pi and approximate to the nearest tenth. So let's do this. What is my formula? It is x out of 360, where that's the central angle, times 2 pi r to find the arc length. It's always going to be the length of my arc. So what angle am I working with on this problem? I'm working with a 60-degree angle. So that's going to be 60 degrees out of 360, 60 out of 360, times 2 pi r, times 2 times pi times my radius. What is my radius? My radius is 11. Okay. When you want to leave this as a fraction, sometimes it's going to give you the whole number. We're going to multiply across the numerator first, and then we're going to multiply across the denominator, so that's going to be 360 over 1. So you're going to type in 60 times 2 times 11. That's going to give me 1320 over 360. Let me write that out. 1320 over 360 pi is the exact answer. So what we're going to do is we're going to simplify that fraction, 1320 over 360. 1320 divided by 360. Y'all are used to this with my calculator, so I'm just going to change that to a fraction. That is going to give me 11 thirds. So what is this exactly? 11 thirds pi yards. So what is 11 divided by 3 and then times pi? That is going to round to about 11.5. It says leave it as a fraction and then also round it to the nearest tenth is what it says. So that's about 11.5 yards. Okay, so here's my exact answer. Let's see what color code I did this. My exact answer is going to be the blue one. That's what it's equal to. My rounded answer is going to be the yellow one because that says approximately. All right, this next problem, I don't have the angle I need. The angle I need is this one right here, but I have 90 degrees right here. So the arc I'm working with is going to be 360 minus that 90, which gives me 270 degrees. So this question mark becomes 270 degrees. So I'm working with 270 out of 360, that fraction of the circumference, 2 pi r, which is 28. So again, I'm going to multiply across the numerator to find this fraction. 270 times 2 times 28 gives me 15,120 over 360 pi. So I'm going to use that as a fraction divided by 360. And I'm going to turn that into a fraction. That's actually going to give me a whole number. That's going to be 42 pi. What is 42 pi approximately? That is going to give me about 131.9 centimeters. So both of these are in centimeters, but one is exact in terms of pi and one is rounded. So we're just going to keep going. This is my central angle. I'm working with 150 degrees out of 360 degrees in the circle, times my circumference, which is 2 times 5 times 7. So again, across the numerator, 150 times 2 times 7. That is going to give me 2,100 over 360, oh goodness, pi. So I'm just going to, y'all, that 6 looks terrible. I'm just going to type in 20, I'm going to simplify the fraction, 2,100 divided by 360. That is going to give me a fraction of 35 over 6 pi. 35 over 6 pi. Whenever they put things in terms of pi, they're going to use the, most of the time, they're going to use it as a fraction, an improper fraction. Okay. 35 divided by 6 is 5.83 repeating, so that times pi is going to give me about 18.3. We are working with my units as well, so I'm going to make sure I include that on each of those. Okay, all right. So there are my, that's how you could format these in terms of fractions, but sometimes I do simplify to whole numbers. Okay. This next one, we're working with how many degrees? So I'm going to change, let's see, the directions are the same. So I'm working with 107 out of 360 degrees. I always look for my degree symbol right there. Of the circumference, which is going to be 2 pi times 6. There's my radius. 107 times 2 times 6 gives me 1284 over 360 pi. So that divided by 360 gives me 3.56. Looks like it's repeating, but let me simplify that to a fraction. Mode. Math, change that to a fraction. That's going to give me 107 out of 30 pi meters exactly. Well, what is that times pi? That is going to give me about 11.2 meters rounded. So if I were to flatten out this black line, it would give me 11.2 meters approximately. Okay, 38 out of 360 degrees of 2 times pi times 15, that's my radius. 38 times 2 times 15 gives me 1140 over 360 pi. What is 1140 divided by 360? It is going to be, as a fraction, 19 over 6 pi. Whenever you do that times pi, you get about 9.9 inches. So we have our exact answer as well as our rounded answer. Okay, now we're working with 315 degrees out of 360. That's the measure of the arc. We're going to multiply that by the circumference, which is 2 pi r. So 315 times 2 times 10, 6,300 over 360 pi. Let's see what that reduces to. So divided by 360. Ooh, 17.5 pi. So you could do 17.5. If we wanted to write it as a fraction, we would write that as 35 over 2. So either way is fine as long as you know that that's the same. 35 over 2 pi centimeters. You could also write that as 17.5, but they did ask me for the fraction. And so what is that going to approximate to? That rounds to about 55.0 centimeters. It's rounded. It was 54.97. It kept going, so that rounds to about 55 centimeters. Okay, so these were your notes talking about circumference and then finding pieces of the circumference, which we call arc length. And then here's our assignment on the back. Notice that your directions say leave in terms of pi and approximate. So I'm wanting y'all to do both of those things, okay, just to get used to seeing both of those answers. And that way, no matter how it's asked for, you know which one to put.